want to talk to you for a couple minutes about what I see as the strengths and weaknesses of reasoning using current best of breed LLM models versus reasoning using explicit, uncertain logic approaches like probabilistic logic networks, PLN, that we're playing with a lot in Hyperon now. Because modern LLMs are super good at reasoning. Like in some ways, it's astounding how good they are at reasoning. They can do complex math proofs. They can, validate and help formulate science hypotheses. They're very smart. In many ways, they're better at reasoning than most people are most of the time, right? On the other hand, clearly they're not replacing humans yet, right? Like while working with LLMs to design new AI algorithms or do math proofs or formulate biology hypotheses, I mean, it's not like I can just give a big task to an LLM and say, hey, do this research project, right? Like you're having the LLM write a bit of code and make some output or make a hypothesis or do some proof steps, and the human is evaluating. The human, me in the work I'm doing, is filtering through the suggestions the LLM made to see which ones are any good and which ones are it's sort of going off the rails somewhere. And then LLM often gets stuck or gets in a rut. I have to come up with some slightly more out there idea, right? So it's an interesting question. Like right now and in the next phase, like which of these shortcomings, even before we get to AGI, which of these shortcomings can a reasoning engine like PLN actually help with it and do better than the LLMs, right? And I think there's a couple different areas popping up from recent experience. I mean, one is throwing out weird creative suggestions that aren't completely obvious given the series of prompts that you're exploring. Like even if you ask the LLM to do that, it does a much worse job than I do or than many other professional researchers do. This isn't what you typically think of as a logic thing, but it's actually something PLN's abductive reasoning modules are extremely good at. Maybe not the same exact way as a human. So there's going to be a period of time when humans interacting with LLMs are injecting a certain kind of creative ideas, and then a system like PLN interacting with LLMs is inserting a different flavor of creative ideas, right? And this can be super interesting, although I think before too long, the creative ideas come up with by PLN and other Hyperon systems are just on the whole going to be better than human creative ideas. I mean, except possibly for domains that are just very tied to human society and human nature, but maybe even there. Another space I think there's a huge opportunity for things like PLN in the near term is any domain we have a mix of unstructured information and natural language, and then structured knowledge, like which isn't just linguistics. Like it could be math, it could be a biological ontology, it could be a bunch of financial data sets, right? Because the LLMs are pretty good at doing reasoning just based on language. Not that you can't beat that, but they're pretty good at it. PLN may be better in some ways, LLMs may be better in some ways, but LLMs are not especially good at dealing with gene ontology and, proteomics and pathway databases. They're not very good at dealing with a whole bunch of crypto time series and associated structured knowledge about blockchains, right? They're not really good at searching the whole corpus of mathematics for related ideas unless you prompt them in highly particular ways. And you get similar issues in less academic domains, like even in marketing. If you have a huge amount of marketing data, which is complex and involves different demographics doing different sorts of things with different products, I mean, you can't just throw that data to the LLM and have it figure it out. I mean, you can use the LLM to help you design Python scripts or Excel macros and go back and forth with LLM and various analytical tools and your human brain, right? Which is interesting to do and can progress fast. But in this kind of thing, being able to put all the structured data into a Hyperon atom space, also using semantic parsing to get a bunch of linguistic data into the Hyperon atom space, and having PLN reasoning, combine the structured symbolic data with the logical relations extracted from linguistic data, and then make external calls to statistical or ML algorithms to crunch some of the quantitative data and bring the results of that back into the Hyperon atom space. I mean, this is an area where we seem to have an interesting upside right now, even before we get to AGI, and we're playing around with this a bit with mathematical knowledge. We're playing around with it a bit in both Rejuve Bio and Rejuve.ai on biomedical knowledge, both related to, human health and personalized longevity relationships and therapeutics discovery. Because in both math and biology, you have this case. We have linguistic knowledge, quantitative knowledge, and sort of structured logical knowledge all woven together. And yeah, this leads back to some of the prototyping we're doing on the Questor product, which will leverage LLMs and PLN and our HyperClaw agent on the back end, because Questor is supposed to be like a research assistant leveraging all these different AI methods in the back end. And I think it's going to be useful for a heck of a lot of things once we finally get it rolled out. But I mean, it may be that among the core differentiating aspects is how it helps with research on these sorts of domains. We have a mix of linguistic, structured, symbolic, and quantitative data, because we already see in the playing around we're doing now that PLN and Hyperon, even in their early alpha forms, in some ways do better than LLM there.